We will now discuss the solution of a problem from the section Real Analysis. The problem is based on the concept of the injectiveness of functions. And this question has appeared in CSIR National Eligibility Test held on 30th November 2020, and it is from the section C. The problem is, let n be the set of natural numbers. Let n is equal to the set consisting of 1, 2, 3 be the set of natural numbers. Which of the following functions from n cross n to n are injective? The four options are given. Option 1, f1 of m comma n is equal to 2 power m into 3 power n. Option 2, f2 of m comma n is equal to mn plus m plus n. Option 3, f3 of m comma n is equal to m square plus n cube. Option 4, f4 of m comma n is equal to m square into n cube. We will now discuss the solution of the problem in detail. Let's recall the definition of the injectiveness of a function. A function f from n cross n to n is said to be injective if f of m comma n is equal to f of p comma q implies m comma n is equal to p comma q. Or, in other words, if m comma n, the ordered pair, not equal to the ordered pair p comma q, then f of m comma n not equal to f of p comma q. Let's now consider the option 1. f1 of m comma n is equal to 2 power m into 3 power n. f of m comma n is equal to f1 of p comma q. f1 of m comma n is equal to f1 of p comma q. That implies, by definition, 2 power m into 3 power n is equal to 2 power p into 3 power q. This implies multiply throughout by 2 to the power of minus p and multiply throughout by 3 power minus n. You will get 2 power m into 2 power minus p is equal to 3 power q into 3 power minus n. That implies 2 power m minus p is equal to 3 power q minus n. And this is the power of 2 and this is the power of 3. They are equal if and only if 2 power 0 is equal to 3 power 0. That is, this implies m minus p is equal to 0 and q minus n is equal to 0. That implies m is equal to p and n is equal to q. That implies the ordered pair m comma n is equal to p comma q. Thus, we have proved f1 of m comma n is equal to f1 of p comma q implies m comma n is equal to p comma q. Yeah, this shows f1 is injective and the option 1 is true. Now, let's now consider the option 2. f2 of m comma n is equal to mn plus m plus n. Note that f2 of m comma n is the same as f2 of n comma m for all mn belongs to the set of natural numbers. This means f2 is symmetric in m and n. Thus, For m comma n belongs to n and m not equal to n, you take m not equal to n, then we have the ordered pair m comma n is not equal to n comma m, but f2 of m comma n is equal to f2 of n comma n because of the symmetry. So that is the two distinct elements m comma n and n comma m of n cross n are mapped onto the same element, that is f2 of m comma n is equal to f2 of n comma m, and therefore f2 is not an injective function. To be specific, we give a counter example like this. f2 of 1 comma 2 is 1 into 2 m into n plus m plus 1 plus n plus 2, that is equal to 5, and f2 of 2 comma 1 is equal to 5. So thus 1 comma 2 is not equal to 2 comma 1, but their images f2 of 1 comma 2 is equal to f2 of 2 comma 1, and this shows that f2 is not injective. Let's now go to the options 3 and 4. So under option 3, f3 of m comma n is equal to m square plus n cube. Under option 4, f4 of m comma n is equal to m square into n cube. Let us fix m. Say m is equal to 1. And choose an n belongs to the set of natural numbers n not equal to 1 such that f3 of m comma n is equal to f3 of n comma m. That implies m is 1 we have fixed, no? So f3 of 1 comma n is equal to f3 of n comma 1. So f3 of 1 comma n is 1 square plus n cube is equal to f3 of n comma 1 is n square plus 1 cube. Cancelling 1 square 1 cube on both sides, we will get n square is equal to n cube. That is, choose an n belongs to the set of natural numbers n not equal to 1 such that n square is equal to n cube. So there are several such n belongs to n such that n not equal to 1, n square is equal to n cube. So f3 of 1 comma n square will be 1 plus n power 6. f3 of n cube plus 1 will be n power 6 plus 1. They are equal. They are equal. So thus for n not equal to 1, we have 1 comma n square not equal to n cube comma 1, but their images f3 of 1 comma n square is equal to f3 of n cube comma 1 by this. So that means this is also true with f4 also. f4 of 1 comma n square is equal to f4 of n cube comma 1 is equal to n power 6. The same example will work here also. So that is, two distinct elements of n cross n are mapped onto the same element of n by both f3 and f4. Therefore, f3 and f4 are not injective. Our final answer is option 1 is true. So that is the discussion of the solution of the problem from the section real analysis, and the question is based on the injectiveness of functions, given functions. I hope that you have understood the solution of this problem and go on working out problems on these lines. I wish you all the best. Thank you.